All right, so now for example number 3, before I write down this formula for example number 3, consider a function f of x. If I take and calculate using like a rectangular approximation, okay? If I take and I approximate using like some sort of rectangular approximation, we could have from the distance from here to here is a to b, okay? So this distance is from a to b. If I wanted to mathematically figure out what the distance is from here to here. Now this distance from here to here is really f of some point c. And so what I could find is, I could find the average area under the curve. In other words, and let me write this down. So if I say the average or mean value of the area under the curve, I could find the average of f as being equal to 1 over b minus a like that. Now what this is doing is, the area under the curve, the area of this rectangle, here's where it comes from. We said that the area of this rectangle is, well, it's the height times the base. And I wrote it backwards on purpose. Well, how do I get the height? Well, the height is some value of the function f of x. It's the y term. So it's f of x. And then my base is just delta x, right? And so that area under the curve is the height times the base, or f of x and then delta x. Well, we said that delta x is really if we just do one rectangle, it would be b minus a, right? Does that make sense? Mm-hmm. Now here's where I'm trying to derive this in front of you kind of quickly. Well, the area under the curve, though, is a raised to the b, right, of f of x, right, dx. Right? Now, if I take both sides and I divide it by b minus a, what I really have is 1 over, and remember, because this is a number, it's a constant, it could be tossed to the front. I've got 1 over b minus a of f of x from a to b is equal to f of x, where this is really the average, right? It's not the exact, right? Does that make sense? You see how I get that? Now the confusing part is you have f of x and f of x here. I don't know. I probably could have used a different function, but that's where all this comes from. The average of f, the average f value, is the area under the curve multiplied by 1 over b minus a. Now, let's do that in an example problem. So for example number 3, they give us the function f of x is equal to 4 minus x squared. And they want us to find the average value from the interval 0 to 3. Okay? Now, if I were to graph this function, it kind of looks like this. It kind of does one of these deals. Okay? So this is y equals 4 minus x squared. And if I were to graph it from 0 to 3, the area under the curve is here, and the area under the curve is here. All right? Now I can find out what that average value is by plugging this stuff in. This is A, this is B. So to find the average, remember we said that the average value of f. So what we're saying is if I take this f value and this f value and this, just the y values of all these coordinate points, and I add them up and divide them up by the sum total, the average y value. What is the average y value? I would get the answer that I'm about to write on the board. Okay? So that is equal to the area under the curve from 0 to 3 of 4 minus x squared dx. Now I can find this area under the curve on my calculator. Oh, wait. I forgot to write one more thing in there, right? I've got to write 1 over b minus a, which is going to be 3 minus 0. That's what the average value of f is, right? Because that's coming from this formula. The average value of f is equal to 1 over b minus a of the integral from a to b of f of x dx. So the average value for f is equal to 1/3 whatever this is. So now I'm going to go on my calculator and figure out what that is. And then at some point in time I'm going to show you how to calculate that. Well, let's just do it now, shall we? Let's do it now. Break through it, get ready for it. So to verify it on my calculator, what I'm going to do is I'm going to plug in my function and graph it. So I've got 4 minus x squared, and I hit graph. And I just need to evaluate the area under the curve. So if I go second trace, 7, lower limit is 0, upper limit is 3. Hey, the area under the curve is 3. So I know that this is 3. So the average value for y is 1. So if I think of each point on this line as x comma y, and if it were possible and I were to take several y values, add them all up, divide by the sum total, my average y value is 1. Does that make sense to you guys? Now let me show you how to get that actual integral by hand. We need to figure this out. 1/3 evaluated from 0 to 3, right, of 4 minus x squared. Well, what's the this 1/3 always stays in the front. Well, what's the antiderivative of this thing? To get 4, I have to start with what? 4x. Very good. All right, now, to get negative x squared, that means it had to be x to the 3rd, which means the 3 got tossed to the front, which got canceled. So this is going to be negative x to the 3 over 3. This takes a little practice. Obviously, I'm an AP Calculus teacher. I should be able to take an antiderivative of a polynomial. But what you can do at this point, every single time if you want to, is stop, take the derivative, and make sure you end up with minus x squared. If I take the derivative of this, the 3 gets tossed to the front, the 3's cancel, and I subtract 1 from the power. So that is negative x squared, right? Now we need to evaluate this from 0 to 3. So if I say 1/3, I'm going to do this. I'm going to say 4 times 3 minus 3 to the 3rd over 3 minus, so this is the b stuff. I'm going to take the antiderivative and evaluate it at b first. Then I'm going to subtract 4 times 0 minus 0 cubed all over 3. Now what's all this stuff over here? 0. It's very convenient for us to cross that out and we get 0. So really, I've just got to evaluate the stuff on this first part. So I've got 12 minus, what's 3 cubed? 27. Then we divide by 3, which is 9. So I've got 12 minus 9. Hey, what does that equal?
3 times 1/3 equals 1.
And that's what we wanted. That's what we got. Does that make sense? We're excited. Okay, you're smart, right? You figured it out, right? This is calculus, right? Good. Any questions on what we did?
Well, can you scroll